General Laboratory Safety. Safety instructions produced by students and staff from the Institute for Inorganic Chemistry, Kiel. Work in laboratories poses potential risks. Therefore, there is always a laboratory supervisor present. His task is to ensure a safe working environment in the laboratory. He is the first port of call for all problems and questions. His instructions must be followed at all times. Before work in the laboratory can begin, the laboratory supervisor presents an introduction of the techniques and laboratory equipment to be used. Furthermore, he will discuss personal protective bodywear, which includes safety specs and a lab coat. He makes you aware of emergency facilities. These include an emergency shower, the eye wash fountain, fire extinguishers, fume hoods, first aid equipment, emergency switch-off buttons, the fire alarm, and the emergency telephone with emergency telephone numbers. He informs the laboratory workers about specific dangers and supervises precautionary methods. Furthermore, he ensures that there is a copy of the Technical Rules 526 for dangerous compounds in every laboratory and makes sure that these rules are being observed. The Technical Rules for Dangerous Substances, or in brief TRGS, reflect the present knowledge of technology, occupational medicine, and occupational hygiene, as well as other proven scientific facts for working with dangerous substances. This includes their classification and labelling. He also ensures that emergency plans and safety information are accessible in the laboratory in a visible place. In addition, he needs to ensure that regular testing is being performed on those pieces of equipment where this is required by law. Operational instructions for special equipment in the laboratory are written by the laboratory supervisor, who ensures that everyone has access to them. They indicate dangers and advise on safety precautions. Operational instructions must be written for biological materials, hazardous chemicals and their preparation, as well as for machines and other technical facilities. They include area of application, danger for humans and the environment, protective measures and rules of conduct, what to do in case of any malfunctions, what to do in case of emergency and first aid, appropriate disposal, maintenance for machines and technical facilities, consequences if these rules are not adhered to. There is also the assessments of dangers. They include dangers which may occur in laboratories and measures which can be taken to prevent these dangers. In addition, the effect of these measures is always documented. Last but not least, there is the safety documentation itself. It includes an inventory of the chemicals in the laboratory. In addition to this, for all chemicals, the safety forms must be accessible in the laboratory. This was an enormous amount of information, which needs to sink in. Let's look at a few real-life examples. Before the lab course starts. This is Adams, and this one here, let's call him Smithy. Both are in their first year and study chemistry. After university, Adams is planning to work in a large chemical company, ideally in research and development. Smithy thinks more about becoming an alchemist and is considering gold production. Both still have a long way to go because beforehand they need to study.
Don't we have lab course today? When is that supposed to start?
Yes, the lab course starts in an hour. Haven't you prepared for it?
Prepared? Why should I? They'll tell us everything.
Well, if you think so.
Adams, what do you look like?
What? Lab codes and safety specs are mandatory. Haven't you read the instructions?
But Smithy, you don't want to go into the lab like this.
But why ever not?
In the laboratory, you must always wear long trousers and proper covered shoes. However, the trousers must not be tucked inside the shoes. No loose hair. Headscarves are okay, but only if they are 100% cotton. If you have problems with vision, contact lenses are not suitable. Glasses are better. What's required of women is also true for Smithy. No nylon tights, no skirts. In addition, students must inform the laboratory supervisor about pregnancy and chronic illnesses, for example, epilepsy.
Hey Smithy, what does that green sign tell you?
No idea. It's probably not important.
Wrong, Smithy. This can be very important in an emergency. Every sign has a specific meaning.
Wow, this stuff has an incredible colour.
What are you doing? Potassium dichromate is mega dangerous. Do you want to poison us all?
Poison. How do you know?
You can tell by looking at the danger symbols.
The what?
Every chemical compound is labelled with danger symbols. These advise the chemists on the danger of the material. A detailed explanation of the different symbols will follow later.
I'll go and get some concentrated hydrochloric acid.
Smithy, wear gloves in case you spill something. Not all gloves are the same. For handling chemicals, there are different types. These are an important means for chemists to protect their skin from coming into contact with chemical compounds.
Okay, this has to stir for 1 hour now.
1 hour? Well, then I'm going to eat something.
Eating in the laboratory, Smithy? That's an absolute no-no. Chemical reagents in food are not tasty for chemists. In addition, keeping food and drinks in the laboratory is also forbidden. The correct handling of chemical apparatus.
Adams, look. Over here I didn't have a clamp, so I just used a clothes peg. I didn't have a stirrer hot plate, so I turned the toaster onto full power. I'll do the stirring by hand. And the cooling hoses are leaking a little bit, but it doesn't matter, because the fume hood has a drain.
I'm beginning to think that you're a little bit crazy. Haven't you learned anything?
When a chemical apparatus is assembled and used, special care must be taken. When doing this, there's no need to be creative, and improvisations are not welcome. The apparatus needs to be well constructed with no tension, and it needs to be stable. Every apparatus requires a pressure vent. You must not assemble a closed apparatus, because this may lead to a dangerous surge in pressure. Electrical equipment must be tested regularly. High temperatures and flammable solvents are a dangerous combination. Therefore, the solvent must be retained by a reflux condenser. An aqua mobile indicates a working cooling process. Cooling hoses with cooling water must be secured. Flammable and thermally unstable compounds must not be heated over an open flame. The heat source must be easily and quickly removable from the apparatus. Boiling retardation can be avoided by stirring. Heating baths must be positioned safely. Hot oil can lead to severe burns. The maximum temperature of the oil bath must be taken into consideration. Even laboratory glass can be dangerous. Hot glass looks exactly like cold glass and can lead to burns. Glass is very fragile and shards of glass can cause cuts. The cooling of a reaction may be performed with various techniques, with ice, a mixture of ice and rock salt, or with cooling mixtures consisting of dry ice or liquid nitrogen with various solvents. Here, you must take precautions that you choose the correct vessel and pay attention to using safety equipment. Generally, dewars are suitable. Liquid nitrogen and liquid helium belong to the ultra-low temperature coolants. In the liquid state, they have temperatures of minus 196 degrees centigrade to minus 269 degrees centigrade. Direct skin contact may lead to severe frostbite. Therefore, low-temperature protection gloves, safety goggles, or in some cases a face shield must be worn when handling these coolants. When decanting, sufficient airflow must be ensured. It is forbidden to remain in the elevator when ultra-cold gases are being transported. Containers must be moved with care and should never be fully closed, thus avoiding a pressure increase. A danger exists in that oxygen from the air condenses in gases at ultra-low temperatures. Oxygen is a strong oxidant. Therefore, there must be no flammable compounds in this container, and the workspace must be free of sources of ignition. Chemical apparatus may be used under a partial vacuum. A partial vacuum is used, for example, for distillations and drying processes in desiccators. Damaged glassware cannot withstand the partial vacuum and may implode. Therefore, all glassware must be examined for cracks before use. Chemical reactions under high pressure may only be performed in suitable certified pressure vessels, which are called autoclaves. The maximum temperature and the maximum pressure, depending on the volume of the reaction mixture in the autoclave, needs to be observed. Pressurized vessels may only be opened after pressure equalization. The experimental apparatus must be labeled accordingly. Gases are either available in pressurized bottles or via gas connections in the fume hood. A color-coding system shows you the properties of the content. Inert gases are marked in green, corrosive and toxic gases yellow, flammable gases red, and oxidizing gases blue. Oxygen bottles have a white shoulder and a blue or a grey coating. Argon bottles have a dark green shoulder and the coating is grey. For hydrogen bottles, shoulder and coating are red. Generally, you must prevent gases from leaking into the laboratory atmosphere. Therefore, you may use gases only in fume cupboards and in gas-tight apparatus. In pressurized gas bottles, gas is compressed. Therefore, they need to be always stored in gas bottle cupboards. This protects them against falling over and against high temperatures. The gas bottle cupboards are ventilated in case of gas leakage. In order to use the gas, a pressure reduction valve has to be screwed onto the main valve of the gas bottle. In order to protect the main valve, you always need to screw a cap on top of it. Gas bottles may only be transported on a gas bottle carrier. Working with electrical equipment. In laboratories, electrical equipment is often used. In this situation, accidents with electricity can happen. You should bear the following points in mind when working with electrical equipment. Electrical equipment is to be used in accordance with its intended use. Different to what you can see here, electrical equipment should be in perfect condition when you use it. Settings and safety precautions must be correctly adjusted. Electrical equipment that is wet must never be used. If there is damage or malfunction, the apparatus must be switched off and a qualified electrician must be notified. It is not allowed to continue using damaged equipment and the dangers must be signposted. Repair work by unqualified electricians is prohibited. Repairs of electrical facilities and equipment may only be performed by qualified electricians. Electronic equipment in the laboratory must be tested regularly. Working with radiation.
Smithy, I don't think we're allowed in here.
You kidding? I'm a student here. Of course I'm allowed to go in there.
Working with ionizing radiation and radioactive compounds requires a special instruction by the radiation safety officer, my dear Smithy. Such work must only be performed at specially designated workplaces. You must limit exposure by employing technological measures to keep exposure as low as possible. Handling ionizing radiation and radioactive chemicals is regulated by the Radiation Protection Ordinance. The principal rule is, everything is forbidden unless you have special permission. X-rays are mostly used in crystallography. There are warning signs and warning lights alerting you to the danger. The equipment may only be used with permission and only after being briefed by the Radiation Protection Officer. Fully protected equipment ensures that nobody comes into contact with radiation. In this instance, X-ray suites are not controlled areas, and carrying a personal dosimeter is not required. Students may use these machines after being instructed. For work with gamma radiation, the same rules apply, but in this case a dosimeter must be worn, which is changed at regular intervals. Laser radiation is often being used in optical spectrometers and as such presents a danger to the eyes. An area in which lasers are being used must be labelled. When working with lasers, special safety goggles must be worn. The competent handling of chemicals. Chemicals must be stored in special chemical cupboards. In all circumstances, they must be labelled by the user or by the supplier. A label gives information about the name and product identification, danger pictograms, H&P statements, nominal content, contact information of the supplier, and a signal word, if necessary. Signal words are attention or danger. In order to recognize dangers immediately, all chemicals are marked with GHS labels. There are altogether 9 general health and safety symbols. The exploding bomb signifies explosive chemicals. The flame, flammable solids, liquids, aerosols and gases, pyrophoric compounds and organic peroxides. The flame above a circle signifies oxidizing solids, liquids or gases. The gas bottle warns of gases under pressure. The corrosive effect of compounds which are corrosive for the skin may cause severe eye damage or are corrosive with respect to metals. And the skull with the crossbones warns of chemicals which are acutely toxic within categories 1 to 3. The exclamation mark signifies chemicals with acute toxicity of category 4 and skin-irritating chemicals of category 2. The upper body with a star represents danger for your health, and the label is used for carcinogenic chemicals category 1A, B, 2, and also warns of the danger of aspiration, sensibilization of the respiratory tract, and target organ toxicity. Lastly, the dead fish is used to label chemicals which may harm the general environment, or more specifically, the water environment. In addition, a detailed estimation of the danger of the chemicals can be performed using the H and P statements. The danger potential of every chemical is precisely determined by hazard statements, or short, H statements. Furthermore, there are precautionary statements, or short, P statements, which give safety advice on dealing with the respective chemical. H statements are characterized by the letter H and a 3-digit number. The first number gives the class of the H statement. 2 stands for physical danger, 3 for health hazards, and 4 for environmental dangers. The second and third digits are consecutive numbers. P statements are sorted into 5 groups of safety directions. 1. General. 2. Prevention. 3. Reaction. 4. Storage. And 5. Disposal. In order to estimate how toxic a chemical is, an LD50 value is determined. The LD50 value is the amount of a chemical which causes the death of 50% of a group of test animals. Toxic or hazardous compounds should always be replaced by less toxic substances, as far as this is possible, in a chemical reaction. For example, benzene can often be replaced by the much less toxic toluene. Experimenting with chemicals while bearing in mind the operating instructions. As soon as you start an experiment, a few things need attention. All experiments must be carefully planned and prepared. Good preparations can be done by reading the description of the experiment and the operating instructions, by reading the labeling of the starting materials and synthesized compounds, dangers for persons and the environment, required safety precautions and codes of practice, behavior in case of emergency, first aid measures in case of accidents, and notes for the disposal of the chemical. Labeling of the reagents and synthesized compounds, dangers for persons and the environment, required safety precautions and code of practice, procedure in case of emergency, first aid measures in case of accidents, and notes for the disposal of the chemical. Before you start an experiment, you must also consider if you have enough time for the entire experiment. If this is not the case, you must decide in advance at which point the experiment can be interrupted without danger. An experiment which needs to run for a longer period of time without supervision needs to be placed in the designated night labs. You must ensure that you have all reagents and equipment ready to use before starting an experiment. Having to search for missing items leads to a hectic rush and therefore to a higher safety risk, especially during difficult phases of an experiment.
I'm telling you, it was an incredibly amazing evening. I've never been to a birthday party as good as that. This girl, blonde, long legs all the way to the ground. Unbelievable. Really. Awesome, you should have been there. I tell you, it was fantastic. Ah, yes, diluting the acid to 2 molar. Oh!
Oh no, Smithy. You know. Acid last and not the water, otherwise it's bound to falter. When mixing acids and water, it is important that the water is added first, because otherwise a violent reaction takes place.
Well, this soup has to ferment now for an hour. I guess it's going to be okay over here as well. The fume hood is full anyway.
This tin is not really ideal. And also the label is missing.
It'll be fine. Oh.
Chemicals must always be stored in adequate containers, and it is vital that they are labelled. They need to be kept either in the fume hood or in specially designated cupboards in order to prevent danger to other co-workers in the laboratory. The label must be precise so that every danger can be assessed, even by a person not involved in the experiment. Now, even Smithy and Adams know that it is better to work in a fume cupboard, but even here, there are a few important things to take note of. The fume cupboard can only suck in the air at full capacity when it is closed. A short demonstration illustrates this. Before work commences, the fume hood should be tested by the user to check that it is functioning correctly. Don't forget to switch the fume hood on. Then, the experiment is placed in the fume hood and the front screen is closed. It is possible to work comfortably through the side openings of the front screen. Never put your head into the fume cupboard, because the heavy front screen can cause extreme injuries. If you inadvertently spill hazardous substances, you should only remove them and dispose of them while following certain rules. It is absolutely essential that you know the chemical and its properties before you wipe it up, because in some instances this would lead to violent reactions. If hazardous liquid substances have been spilt, you must use special resins. This will help you absorb the liquid. If fine powders are spilt, they must be congealed with water. All waste must be disposed of appropriately.
Hey, Smithy? Hey, Smithy, carrying chemicals is only allowed in a bucket.
Wow, I need a coffee now. Big time. Yo, Adam, coffee?
Hygiene is extremely important in the laboratory. After work, hands must be washed thoroughly so that no chemicals from the laboratory can be transported outside. Working clothes, such as a lab coat, safety goggles and so on, must be stored in the designated lockers. These items must be worn in the lab, but under no circumstances outside the laboratory. Danger in the laboratory through flammable and explosive chemicals. In the laboratory, flammable and explosive chemicals present particular dangers. Among these are solvents, alkaline metals and hydrides, silanes, nitroso and nitro compounds, azides and fulminates. Solvents, which are often highly flammable, require special measures for handling and storage. Overheating, proximity to flames and sparks are to be avoided. Storage in special fire-protected safety cupboards is obligatory in this case. Self-inflammable chemicals may ignite when in contact with air and water. They are, for example, alkaline metals and hydrides, and also silanes. Shock-sensitive chemicals carry the danger of explosion. Nitroso and nitro compounds, azides and fulminates require careful handling. Shock, friction, and solid inclusion must be avoided in all circumstances. In order to react quickly in case of fire, It is important to inform yourself about the fire extinguishers in the laboratory and how to use them. The fire extinguishers you will find in the laboratory are classified according to their extinguishing effect for different classes of fire. ABC powder extinguishers are suitable for burning liquids, solids, and gases. Burning metals, however, must be extinguished using sand. Human bodies that are on fire can also be extinguished with a fire extinguisher or an emergency shower. If a fire is too large, the building must be evacuated and an emergency call to the fire brigade must be made. The fire brigade will ask the following questions, which you should answer calmly and objectively if possible. Where did it happen? What happened? How many injured persons? Which injuries? It is imperative to wait for further questions and not to terminate the call. Danger for health through resorption of chemicals. Hazardous substances can have a health-damaging effect on the human body because of their acute or chronic toxic effects. These are, among others, corrosiveness, carcinogenic effects, or teratogenous properties. All these factors are taken into consideration for implementing the classification and labelling of chemicals. Poisoning can cause several different effects on the body. Symptoms may occur suddenly, acute poisoning, or gradually, chronic poisoning. Chemical compounds may be resorbed in different ways. For example, inhaling via the lungs, that is, gases, aerosols, and in general, respiratory poisons, orally via the digestive system, or dermally via the skin and mucosa. The most common way of exposure for the human body is via inhalation. It is a lot simpler to prevent oral incorporation or resorption via the skin. As soon as a toxic chemical gets into the body, it is distributed via blood circulation. Irrespective of the symptoms experienced in the area of exposure, specific effects in the body occur. The local effect on the place of exposure of the skin or the mucosa, for example chemical burns by bases or acids, is irreversible. On the other hand, the resorptive effects are often reversible as long as countermeasures are taken in time. The general rule is avoid contact with dangerous substances. First aid in case of chemical accidents.
Hey, Henry, can you tell me the time?
About half to opening, Smithy.
Opening? What? I don't understand that. Gerald, just tell me the time. In normal English, please.
Almost 10:30, but Henry just told you.
Gerald, what's wrong with you? Say something. Say...
Now it is high time for the lab supervisor to react. He immediately proclaims an accident and asks everyone to leave the laboratory. Switch off gas, water and power supplies. Help injured persons only if it does not put yourself in danger. Try to keep calm. Hectic actions may cause further danger. Thoughtful and professional action is now required. Make an emergency call and answer the following questions. Where did it happen? What happened? How many injured persons? Which type of injuries? It is imperative to wait for further questions and not to terminate the call. Be a first aider. Every person working in a chemical company is asked to enroll in a first aid course. In general, you should pay attention to the following. Burns must be cooled with running water for at least 10 minutes. Fresh air must be provided. Exposed skin must be washed with a lot of water. In case of eye contact, the eyes must be washed for at least 10 minutes with the eye shower. For this, keep the eye open with your thumb and forefinger. In emergencies, use the first aid kit. Unconscious people must be placed on their side in the recovery position. The body temperature of injured people must not drop. Generally, all accidents must be reported to the head of the laboratory or the assistant, and because of insurance issues, must always be documented. Respiratory safety guards as a life-saving process. As we have just seen in the film, using respiratory equipment in emergencies can be life-saving. Even in the day-to-day running of the lab, there are cases where respiratory protection is important to protect your life. Air consists of 21% oxygen and 78% nitrogen. However, air can also contain harmful substances in gaseous or solid form, which can be toxic even in low concentrations. In a laboratory, such compounds are often being produced. Suitable respiratory protection is required to prevent intoxications. This will work if the concentration of the harmful substance is not too high or the oxygen concentration is too low. Even fine particle dust leads to significant dangers. As you can see in the example, it is dispersed in the air, can be inhaled, and reaches the lungs and in the end the cardiovascular system. Cleaning and waste disposal.
Actually, I was going to do a really exciting reaction in an hour's time, but the flask is totally dirty and cloudy.
It is better to clean all glassware immediately after use with solvents of low toxicity, such as acetone or ethanol. In this way, residues don't dry up and will be easier to remove. Residue that is difficult to dissolve can be removed using bases or acids.
Look, Smithy, this is what a flask should look like. Then things with the reaction go smoothly.
Like with the girl next door. Now quickly put everything in the drain, then call it a day.
Whoever works with chemicals should also think about their appropriate disposal. Always remember, clean up as you go along. In a laboratory, there will be dangerous and toxic waste, which requires separate waste disposal to protect us and nature. For this reason, there are special containers in which the waste is collected and disposed of. How you should dispose of a chemical can always be found in the safety information sheet. Working in a laboratory is always potentially dangerous. However, you should not be afraid, but work with concentration and the necessary respect for chemistry. It is important to inform yourself about any dangers before commencing work. And Smithy, if you had watched this little film before your lab course, you would be in much better shape today.